So, my name is David Fern. My role at Arrow is I'm the global head of our data and AI business globally, hence the global bit. And essentially my role is to consolidate and understand our strategy and our direction for our data and AI businesses. But I don't only think about data and AI. I'm also one of our lead technologists, so essentially someone who helps customers understand vision and understand what technologies are going to be relevant and sort of pertinent to our partners and to their end customers going from now into 5 years out. But first and foremost, one of the big questions I always ask is, why exactly does this matter? Why do I care about future technologies? I need to sell stuff today to essentially hit my targets and make sure that IBM and Arrow and my sales team are happy. Well, the reality is that the innovation curve, or the innovation sort of line, has always been exponential. Innovation is occurring all the time in our sector. And up till now, what we've seen is adoption lag behind. We call this maturity or risk avoidance, but that's kind of been the enterprise IT world for as long as I've worked in it. But very recently, what we've started to see is actually innovation and adoption converge. And in some cases, some organizations actually start to innovate above the normal rate of innovation to actually solve and create value through technology to drive and sort of determine how they're going to go and do things. Facebook, for a great example, have just open sourced a piece of software that they developed in-house because nothing was created to deal with the amount of traffic they had. So they've just open sourced a product called Scribe, which can literally flow 2.4 terabytes of data a second, because that's the kind of throughput they need. That's where they need to innovate too. So why is this important to you guys? Well, the reality is that as innovation starts to exceed maturity is one of the key selection criteria for all of our customers, we need to be able to guide that roadmap. The new value add to an end customer is no longer what, fulfill me an order or get me a price. That's part of the value. But owning the customer's vision, owning the customer's roadmap, not for next month, not for the next 6 months, but into the next year and the multiple years after that. Where are they going to go? Where can you see opportunities for technology to come in and digitally transform their business and grow it way past where it is today? So, I hope everyone's on board. So we're going to take a look into David's crystal ball. So this is essentially my top trends, technologies, and concepts that I think that we need to be starting to think about, starting to take into consideration. Hopefully I can bring each one of them back to why I think this particular trend or concept or technology is relevant to start to look into today. So we're going to break these into near-term, medium-term, and longer-term visions of the future. And we're going to start with near-term. So, our first one. Now, we, as individuals, all have really great ideas about how we could utilize the information, the data in our businesses better to drive more value out of the data we have. But the reality is we're currently hamstringing our employees with tools like Excel. We're using data that's multiple generations out of date. We're not giving them the tooling they need to be able to go and actually really drive the value that exists today in the market out of the data they have in their hands. So let's just give them AI and machine learning, right? Wrong. At the end of the day, machine learning and AI is hard, right? There's a real barrier to entry. But that's where organizations like H2O, who are a really strong partner with IBM on Power, and IBM's Auto AI on the cloud, remove that knowledge, cost, and time barrier to entry from giving organizations the power to use machine learning and AI to drive real results. Driverless AI, Auto AI, these are systems that today can take data, automatically organize it, select the best possible model to train something for you to then be able to actually infer, start to ask questions of the data. This is something that any organization can start to take advantage of and actually start to deliver value. And not meaning to plug my own session, but I'm also doing the AI session next, and I'm going to show you how to do this in real time. So actually, my session's the best. And my prize is the knowledge you're going to be left with. So that's the first one. Think about how you're going to automate people's data discovery. So next is automation. Prolific automation. Okay, over the next year, so by the end of 2020, Forrester predicts that we will have 1 million, not low-hanging fruit jobs displaced, not highly repetitive, low-skilled jobs, but knowledge worker jobs replaced by robotic process automation, software robotics, chatbots, and virtual assistants. This is, today, a $7.7 billion opportunity, total addressable market, which is currently 20% saturated. Only 20% of the market for automation, both in sort of operational level and also actual worker, knowledge worker level, is actually being dealt with by the providers and by people like yourselves. It's a massive opportunity, 80% of $7.7 billion, which, by the way, is then predicted by 2023 to grow to $12.6 billion and displace over 1 million knowledge workers, by the end of 2020. Massive opportunity. Automation, automation, automation. Automation first, have a human being do it second. That's how we need to start to think. Next, security. So someone once, well, very recently, I was at a security conference over in Vegas, and they said the most secure way today to store your information is write on a bit of paper and lock it in a safe. Honestly. But the reality is that doesn't work inside the paradigm that we've developed for ourselves around having data access where I need it, when I need it, at the speed I need it at. So we need to continue on the cycle that we've got with security. But we need to think about security differently. Who here thinks that this year, very quick show of hands, this year we are a more secure world than we were last year? Good. Because this year we are 363% up on data breaches versus last year. 10.3 billion records have been exfiltrated from Facebook, from governments, from public sector, from education, from healthcare records by attackers. We are not in a good place as far as security is concerned. But the security tools are increasing. They're getting better. But we need to think about how we apply them. And this is where this particular prediction is risk-based security. Think about security, or more importantly, think about the service you're delivering and rate it. Don't just have the traditional front door firewall and then your, big, what we call sort of big iron kind of security products. Think about actually securing the service you're delivering. Think about how you're going to rate that based on risk to the organization, risk to my operations, risk to my financial status, and probably most importantly nowadays, risk to my reputation. Risk-based security, think about securing services rather than servers, and think about how you're going to wrap those services with their own customized, properly sort of personalized security to that service. And then serverless computing. This is the last of my near-term predictions, but serverless computing. So interestingly, I started off my presentation, I did this presentation earlier this year, and I started off with serverless almost everything. Think about serverless almost everything. But in September, Pat Gelsinger, who is the CEO of VMware, stood on stage, and the reason it was serverless almost everything is because fundamentally VMware, who are a big partner of IBM's, turned around and said that we are going to fundamentally re-engineer our entire platform. 80% of the entire world's data centers run on VMware, right? And they basically said we're going to re-engineer VMware to fundamentally run on top of containers. Run serverlessly. Run with Kubernetes fundamentally baked into it. They've gone and employed the 3 guys that invented Kubernetes from Google and employed them into VMware. That's a really serious pledge, and that kind of makes you think we need to really start to take containers and PaaS and SaaS and all these different technologies, and instead of thinking of them as kind of tertiary opportunities, start to think of them as the fundamental way that we are going to do computing in the future. serverless, serverless, serverless. I don't doubt for a second that my son and daughters, if they go into IT in the future, they will never have actually seen a physical server. They won't really understand the paradigm of CPUs and RAM. They'll understand microservices, they'll understand container size, they'll understand SAS and PaaS and time that they need to do things. We need to start thinking, we need to start preparing our customers for this reality. So, that's the end of the sort of real ones, and now we get on to the more fun ones. Medium-term predictions. So the first medium term is IoT Business Systems. Now, you can't come to an Arrow presentation and not hear something about IoT. So as Matt alluded to, about $14 to $15 billion of our entire revenue comes from our global components business. A massive part of that is transforming into IoT, both sensors and embedded systems through to entire boxes that you can go and deploy and scale and put wherever you want to in the world. But still today, IoT is a bit of a DIY job. It's a bit of a kind of, all right, I'll sell this, but I don't really understand how it integrates into this, and I don't really understand how that works with this, and I don't really understand how it becomes a scalable business platform. It's still a bit, without meaning to put it down too much, a bit hacky. IoT Business Systems is where we can start to sell everything completely containerized, completely supported, totally scalable, and that doesn't just mean being able to put lots of these boxes in, it means being able to maintain and support and aggregate the information that we get from them into real-world business value. So this is going to be something that we see come up over the next few years. So this is one of my personal favorites, and my fiancée at the back, Helen, knows how much of a massive fan of Elon Musk I am, and a massive fan of SpaceX, and subsequently a massive fan of what he's doing to introduce post-classical communications to the world. And what I mean by post-classical communications is we all need to start to think, once again, this is a bit of a future one, but we need to start to think about how we're going to leverage these next generation communication technologies. Before 2030, Elon Musk will have put 42,000 new satellites into space to give a complete global coverage of super high bandwidth, super low latency, everywhere, always on satellite broadband. Not like the satellite broadband of today, but the satellite broadband of new. And that's great, but that's not really what I'm trying to get at. What I'm trying to get at is what opportunities that opens to us when we're talking to customers. How can we connect them better? How can we deliver information to them in a more real-time way? How can we make sure that wherever they are, wherever they happen to want to work, they can connect? And in the same vein, 5G is going to come along and absolutely revolutionize and transform the way that we think about using mobile devices and the way that we think about being able to deliver information and data. 5G, for me, has three major sort of bits that it's going to deliver. The first is bandwidth. It's slated to offer 2 gigabits per second, so faster than an Ethernet cable to your mobile phone. That's great, but actually, that's not the biggest one for me. The biggest one it's going to offer is sub-millisecond latency. At the moment, it's about 300 milliseconds round trip to send a piece of information or gather a piece of information, which basically makes mobile computing utterly useless for real time. Oh, that's what I'm saying. But the reality is, once we go into 5G, sub-millisecond latency, massive bandwidth, and then also dealing with the contention issue. So when you're in events, when you're in arenas. So I get so annoyed when I go to a sporting event or a concert, or I'm just sitting on the train in King's Cross, and I've got really strong 4G signal, all the bars, but literally about 50 kilobits a second. It's because I'm contending for bandwidth at the actual antenna. Right? So I'm contending with everyone else on the train and everyone else in King's Cross for access to that data, or everyone else in the stadium. The reality is 5G will fix that because they're going to have almost infinite sort of low contention in the actual antenna. Why does that matter? Well, if I can guarantee that I can actually deliver high bandwidth, low latency to everyone in a stadium, that opens up loads of new business opportunities for me to be able to deliver more enriching content, to be able to offer more personalized experiences for people in stadiums. It opens up a new opportunity for me as a provider to leverage that technology to do interesting things. Super specific intelligence. So I'm sure everyone here has heard of Google's DeepMind project or DeepMind division. So essentially this is their unbelievably clever AI geniuses, and they developed a piece of software called AlphaGo. Essentially, it went and played the game of Go, this ancient Chinese game. Played a chap called Lee Sedol, who is the Grand Master of Go. Just to give you a bit of context in case you haven't heard about this, but Go is the most complex game on the planet. It has more moves than there are atoms in the universe. It's nearly, it's an incredibly complex thing to do. They beat the world's Grandmaster with this piece of AI software. Super specific intelligence. This thing was the most intelligent playing computer on the planet. But if I then lifted it and got it to play chess, it would completely fall down. Super specific intelligence. What do I mean by this, and where is it applicable to the people in the room? What Google did with this project was essentially knowledge compression. They took essentially all of the knowledge of the grandmasters of Go and compressed it into a network that was a couple of gigabytes big, and then essentially ran it against this guy. We can use that same principle for anything where we can train and understand the context of a situation. So I'll give you another bit crazy example, but this one I really enjoyed. There's a company called June. They make ovens. They use the same principle to compress the knowledge of all the great chefs to cook steak. And now this oven cooks steak better than a Michelin-starred restaurant could cook you a steak in your home by just putting the steak on the plate. It looks at it with computer vision, turns it at the right place. You see, perfect steak every time, because they've compressed all the understanding of how to cook a steak, all this knowledge, compressed it into this tiny little piece of software and deployed it. Think about how you could apply that to other areas of business. It's a massive opportunity. Super specific intelligence. And long term. Now this is where I really have fun. So once again, you can't come to a tech thing and talk about the future without talking about blockchain. It's getting there. It's definitely getting there. It's been a solution looking for a problem for many years now. Bitcoin has done a huge amount of damage, to be quite frank, in its reputation. ICOs and all this kind of crypto crap has really done it a lot of damage. But the fundamental technology is really, really clever. IBM have got a fantastic offering in it called Hyperledger, which is on the cloud. You can run it on Power, on Z. Super, super, super clever technology. If you're looking at anything that needs to have a completely immutable log of what's gone on, really, really useful. Another place where this could be really useful is in possession. So say I have my identity, and I have the identity of something I've bought, say a diamond or anything else. I can prove ownership by essentially putting the record of my ownership of that particular product or whatever it is, and myself onto the blockchain, and then no one can ever turn around and say that I don't own it. And when I sell it, the person that's buying it off me doesn't have to trust that I own it. They can prove that I own it. Trustless systems will become really, really important in the future, especially when we start to become a more globalized civilization where we do need to be able to believe and just trust in an underlying system rather than a person, that ownership and sort of commodities are passed between one another. Great opportunities, problem looking for a solution, or solution looking for a problem, but IBM have a really cool offering in this space. Voice. Voice is the next UI. So it's fascinating. I've watched, I've been using computers since BBCs, those big horrible things, and I've seen the user interface diversify over time. I've seen it just be keyboards, then the mouse, then touch screens. What's next? Last year, Amazon sold 111 million Alexas to people just in the US. So I couldn't find a nice stat that sort of rounded up the global market. But if you combine that with the European market, with the Chinese market, with the Googles and everyone else's products, that's a lot of people interacting on a day-to-day basis with their homes, or their whatever it might be with their voice. And actually, if you think about it, why are we still typing in questions to Google? Why are we still typing in and writing formulas when we could just ask for that data? We could just say, hey, whoever, give me the answer, sales over time for this particular region. Boom, it does it for you. Why are we not using voice as the next UI? Voice will be, by the way, the next UI. Whether we like it or not, the next generation of consumers of IT will want to talk to their computers, and they will not have the social discomfort that we have over doing it. And lastly, now I was torn whether I put this in medium or long term. This is a quantum computer. Now, quantum computing is one of these things that everyone's kind of heard of for a few years. No one really understands. Even the people that actually develop the damn things don't fully understand how they work. In fact, actually, I was watching a documentary the other day where the guy said, we don't know how they work, but we know it does work, so we can take advantage of the quantum principle. Brilliant. That's fine by me. That's absolutely fine. But the reason it's kind of on the line for me between a medium-term guess or a medium-term prediction and a long-term prediction is because about 2 weeks ago, Google reached what's called quantum supremacy. Now, quantum supremacy sounds like something that name of a James Bond film or something. But what it really means is that a quantum computer did something practical that a traditional computer couldn't do as quick. So basically, it calculated some formula in 3.5 minutes, I believe, which took the IBM Summit, so the fastest supercomputer on the planet today, which is the IBM Summit supercomputer at Oak Ridge, 3.5 days. Right? That's pretty darn impressive. Now, obviously, you're not going to put one of those in your data center. And by the way, that's it with its chassis off. To actually run it, you need to cool it down to almost absolute zero and all sorts of other crazy things. But the reality is, put one of these, essentially have it as part of a cloud offering where you can deliver quantum optimized workloads through a cloud, like the IBM cloud, and essentially send something that could be optimized really, really well on a quantum computer to a quantum computer in the cloud, have the results come back, and finish off processing them or use them to add extra information. Super useful. Quantum computers will revolutionize computing. Mark my words, they will absolutely revolutionize computing. And the reason they'll do it is not because I'm saying it, it's because the cost of doing the alternatives, so the cost of drug discovery, the cost of new material design, the cost of figuring out, so optimization. These things are fantastic at optimization. The cost of doing it in the classical way outweighs the cost of buying, developing, and running a quantum computer. And at the point where the cost becomes less to do it on a quantum computer than it does on a supercomputer, it's just fundamental finances, right? So, quantum computing, that's my last prediction. And with that, I hope you found it useful. I hope I've helped to kind of start the day. And I'll hand it back to Matthew.